All right, so this is related, okay? And the reason why we bring it up is because when you put money in a bank account, or like you have interest owed on a credit card or something like that, it gets compounded, okay? Compounds with interest are rational exponents. So the reason why I came to school today, I was going to mark your test, finish them this morning, and then I realized, like, in order to kind of move forward, we have to have some understanding of what rational exponents are. Okay, they're not crazy hard, okay, but they're different. Okay, and there's something that, like, you guys have familiarity with what a square root is and what that is, but what does a square root look like as a rational exponent? A rational being, as we can see here, rational exponents are just simply fractional exponents. So your question today is like, how do I switch from something that looks like this into an exponent? That's the relationship that we're going to try and develop here, okay? So you guys can read, a rational number is a number that can be expressed as a quotient of two integers, like a fraction, okay? That's basically, it's just a fraction. But the denominator, this is the important part, so the bottom part of the fraction can't be 0, because what happens if you guys try typing something into your calculator? Divide by 0. Okay? You guys try typing something, divide by 0 in your calculator, you're going to get an error. Okay, you can't divide by 0, it's not allowed. Okay? And so that's just the one stipulation that you have with basically all of fractions, is you can't have a denominator of 0. Okay, so it doesn't matter where the fraction is, if it's just a regular fraction or if it's in an exponent like what we're doing today, this can't be 0. Okay, so again, just rational exponents are just fraction exponents. Okay, so what I want you guys to do here for a sec is most of the time what I think you guys could do is type in your calculator. You could have like hit the square root button. You could type these questions in and see what happens. Okay, so you get square root 9 times, you might have to hit the arrow key to get out from underneath the square root, times square root 9. Okay, and then you hit equals. What do you get if you've done it correctly? This is why we'll do this once. What do you get? 9. So that's interesting. Square root of 9 times 9 equals 9. Something interesting is happening there. Right? Now, just for everybody on our calculators that we have in our classroom, in case anybody did not get that, what you're going to hit is the little square root button. This will be the sequence that you hit the buttons in case anybody messed this up. Okay? And then you can try the next one. We're going to take square root 9. I think I put one. Maybe put one on your desk. I don't know. Okay. So hit this button, and then you're going to have to hit the right arrow on your calculator, right? Looks like this. Just to get out from underneath the square root, and then you can do your thing. Okay, so then you'll multiply square root 9. Okay, and then hit equals. Should get 9. Okay, so if we do it again, you guys practice. If you didn't get it the first time, try it this time with the 16. But what do you think should happen? Do you think anything magic is going to happen between this line and this line? Like, what do you expect the answer to come out to be for this? Okay, without even typing in your calculator. What? What's the square root of 16 times the square root of 16?
16.
All right. And then we should also see that it's square root 4 there, right? Square root 4 times square root 4 would be 4. Now, so why? Our question is, why is this happening? Now, this part you guys might want to take note of as just being something that is what it is. And until this point in time, you probably didn't know that this was the case, okay? And this is the last few days have been your experience dealing with exponents. Today, we're just going one step further with rational exponents. But the square root sign, does anybody know why a square root is called a square root? Like, we all know this as being a square root, and it doesn't matter what we put on the inside, right? But why do we call it a square root? For the same reason, it's the exact same reason that we call something that looks like this a cubed root. Why do we call that a cubed root? because there's a little 3 inside the hook. Okay, so a square root is that. There's a little 2 inside the hook of the square root button. Okay, you just don't ever see it because it's implied that it's a square root. If it's not a square root, we indicate that with a 3 or a 4 or a 5 or whatever number you want. Take the 7th root or something if you wanted to. So, that being the case, we can always rewrite this as being this. We take whatever number's inside of the little hook, and it comes up to the bottom of the fraction, okay, on the exponent. This explains why we saw the pattern on the left side. Okay? Now, we just finished doing all morning, or the morning period, we just finished doing everything to deal with power laws. So how do I deal with this particular situation? I have 2 bases that match. Does everybody agree? The base being 9 in this particular spot. Does everybody agree? And what do I do when the bases match and I multiply the bases together? What's the rule? You have to what with the exponents? You guys are killing me. What do you have to do? If it was this. Thank goodness. Add. You add this. Nothing's changed. You got a base. I don't care what the base is. In this question is x. In this question it's 9. So when you have 2 bases that match and you're trying to multiply the bases together, you add the exponents. So you get 9 to the 1/2 plus 1/2. What is 1/2 plus 1/2? 1 whole. 9 to the 1. Does that or does that not check out with the answer that we got on the other side? It's 9 to the power of 1. Right? You can expect to see the same thing happen over and over again, right? We get 16 to the 1/2 times 16 to the 1/2. It's going to equal 16 to the 1. Or another way of writing that would be 16 to the 2 over 2, which reduces to 16 to the 1. So again, it works out that we get our answer. Right? And same thing down here, 4 to the 1/2. We probably didn't need 3 examples, but it's all right. Okay? So what's the conclusion that can be drawn, I suppose, is our question, right? We're going to say, okay, well, 9 to the 1/2 is equal to the square root of 9, right? Or we can write it more generally. I shouldn't have the line there, but nonetheless, here we go. We can write it as any base a to the power of 1/2 is equal to the square root of a. Okay, does anybody have any questions? That's brand new, right? I don't think anybody's ever seen that before. Okay. The interesting thing is, we all know, let's do something easy. Let's do something easy. We all know what the square root of 4 is. What's the square root of 4? 2. Okay, it's the square root of 2. You guys can type that in. What would happen if I told you to type this in? Actually, probably don't need a bracket. 2, and then I want you to hit to the where you guys put the exponent in, but it has to be this one, x to the little box, where you specify what the exponent is, but be careful. Hit that button, and then go open a bracket, 1 divided by 2. Close the bracket. Tell me what you get. Oh, sorry. 4, sorry. 2's our answer. If you've done that correctly, when you type this in, into your calculator, you should see that you get a number of 2 out. Do we agree? That's confirmation that the square root and the square root of 4 is 2, and also 4 to the exponent of 1/2 is also 2. Okay? That's all that's going on here. We're like switching between like having square roots and fractional or rational exponents. Those are the two things going on here. Okay? And they can get, like, you could take the cubed root, you could take the 4th root, you could take the 5th root, 6th, 7th, 8th root, whatever you want. I don't know what the 8th root would tell for you, but you can do it. Okay? So we come down here, using our knowledge of the first question, what do you think is going to happen here? Without even typing it in. You guys have a cubed root button on your calculator, I believe. Somewhere, maybe. Yeah, you'd have to hit Shift and then the square root button. It's in yellow, right above the square root button. Okay? It's got a little 3 inside of the hook. So if you type that in your calculator, what do you think is going to happen? If you just took a guess, based on our experiences so far in this lesson, what do you think the answer would be for part B there, the example? The first one, 8, right? I would guess and venture an 8. Okay? And similarly, down here below, we should see 27 if you type that in. Now again, we can answer the question why. Why does this work out? Well, another way of writing this, and this is hopefully it will lock in what I told you in the first part of the question. We can rewrite this as being 8 to the 1/3 times 8 to the 1/3 times 8 to the 1/3. And what do we do when we have bases that match and we're multiplying? We add the exponents. Right? So we get 8 to the 1/3 plus 1/3 plus 1/3. You get 8 to the 3/3, 8 to the power of 1. And you could do the exact same thing. I won't do it because we don't have much room, but you could do the exact same thing with the 27. Okay, so generally, again, down here at the bottom, you could say 8 cubed rooted, right? And you guys could practice and make sure you get the answer is equal to 8 to the power of 1/3. Okay, and so our general rule would be if I took the cubed root of a, that goes as a to the 1/3. Okay, so wherever the number is in the hook, whatever the number is in the hook, it goes to the denominator of the exponent. Oops. Okay, you just follow it, always. These two interchange. Does anybody have any questions? Okay. I think that's what I wrote right there on the next side, okay? So put it in the box. Do we have any questions, comments, and/or concerns? So, the question has to be asked, well, how could I make this more complicated? Because the first side wasn't too bad. Well, obviously you could have rational exponents, like fractional exponents, raised to other exponents, right? Or we could have quotients involving rational expressions, right? Where we subtract, we're going to end up subtracting fractions, which we might have to do some revision of adding and subtracting fractions in order to be able to do this efficiently, right? So for right now, I don't think we're going to do any of those, but what we can do is take the same rules that we learned this morning. I have a power. Doesn't matter that the power is irrational, it's an exponent, and it's raised to another exponent. And what do we do in that instance? We distribute it in, right? Okay, so now I'm going to get something. What's 1/2 times 3. Remember, I can always divide something by 1. How do I multiply fractions? Top times top and bottom times bottom. So I'm going to get 9 to the 3 by 2. Now, you can do one of two things at this stage. You can type in your calculator 9 to the exponent 3 over 2, or you can rewrite this, and you can write it like this. And I'm going to have, when it comes down to actually solving or saying, here, give me a number or a final answer, I don't care what you guys pick, but sometimes I will say, switch this into a square root, or what we call radical form. Another word for square roots is radicals. It's kind of a cool name. Okay, so I'll switch from like a rational exponent into a radical. Okay, and I'll force you to switch it. So this is the force that I'm going to make you do. Right? You're going to say, we're going to get, where does this number go? You guys remember? We just did it. Use your general rule. Where's the bottom of the fraction go? On the square root. So I'm going to draw myself a little hook. This is what I'm looking for, right? So some form of root, right? I don't know if it's cubic, quartic, if it's a square root, whatever, right? I put the number from the bottom of the fraction inside of the hook, and I leave the rest of it alone. So you can go the square root, the way this reads would be, it's the square root of 9 cubed. That's how you would read that off. There's two ways of reading the exact same thing. You could type either or into your calculator. It should work. You could type, okay, do 9 cubed and then square root that answer, or you could type in 9 to the exponent 3 over 2. Okay, is anybody completely lost right now? I think I was doing okay. I feel okay about the way I'm delivering it right now. Okay. Okay, what about this one? Same idea. My exponent is 2 over 1. You multiply the exponents when you have exponent raised to exponent, or power to a power. So you get top times top and bottom times bottom. So you're going to get 64 to the 2/3. Again, you could type that in your calculator to get a number. Or if I said write in radical form, you could write it like this. Draw yourself a little hook, right? You don't know what kind of hook it is yet. You take the number from the bottom of the fraction in the exponent and you put it in the hook. Right? And so we get 64 squared. This one would read cubed root of 64 squared. Is everybody okay? I'll leave that there for a sec. Let everybody catch up. If I said evaluate, then you guys could actually give me a number. Okay? In one of those two ways. You could type in 64 squared and then take the cubed root, or you could go 64 to the exponent 2 over 3. Okay? Anybody have any questions? I'm going to write a there for statement here, a little general thing, okay? So sometimes people like this, sometimes people don't like it. I don't know. We'll see how you guys feel. So therefore, we can write something like this. If we have a base, a, and it's raised to the exponent m over n, that can be equal to a to the 1 over n m. Okay, all I did was take the m from the top, right? It's the same thing as writing this over 1, right? I just kind of went backwards from here, right? From this. Kind of went the opposite direction, okay? 7 over 1. And then we have one more equal statement that we can write. Well, this is equal to the nth root of a, all raised to the power of m. All three of those things are the exact same thing, written in different ways to suit different situations. Sometimes, you know, I think it's a preferential thing, what people like to do and what they want to type in their calculator and how they get answers, right? So we try to show you as many ways as we can to get the same answer. Okay? Now, I don't have solutions for this, so we're going to do it together, and then I'm going to let you guys go and do some questions off the sheet. Okay? All right. Not too bad once you see a couple of them. Okay? What I like about this is like it's reinforcing some of these power law rules that we've seen over the last 2 days, right? And then we're taking it one step further. Okay? It's good, like, if you weren't here, you can kind of get caught up a little bit, or if you find the power laws too easy, this is maybe a little challenging too, okay? So we can say, okay, how do I rewrite this, is your question. Well, I would say you could type that directly in your calculator and you should see, you're looking for what is the base such that when I cube it, I get 125 is your question, right? But another way to write this, you could type this directly in your calculator and get an answer of, you should get 5, if I'm not mistaken. Or, if you don't like that, you can do this. You could rewrite this and say, okay, if I said rewrite this in radical form and give me an answer, then you could do this. Write yourself a radical, a little square root. What number goes inside the hook, the bottom of the fraction? Oh, that looks familiar. It's the cubed root of 125 to the power of 1. So basically the cubed root of 125 we should see as being 5, if I'm not mistaken. Am I correct? Good. I guessed. Okay. Now, next one's a little trickier. Okay. The problem is, what's the problem? We don't like what? We don't like negative exponents. What do we do with negative exponents? Hey, you okay? So we just flip it, right? Remember, this would have been all over 1 at one point in time, so we just flip it. Top and bottom, we find the reciprocal, as we call it, with the real math word instead of flip. But nonetheless, get this job done. Now, you could type that in your calculator, or you could go, okay, well, this is the same thing as 1 over, write yourself a little radical. The bottom of the fraction goes in the hook. It's the 4th root of 1296. You can get a number. Now, how do we do this is the question you guys should be asking. Oh, I see it. Okay, so this would be, I can't change the camera, but I will after, just to show everybody how it works. Okay, you should see, you're going to hit shift. Yeah, you're going to hit shift, and then you're going to see this button, right? X to the power of wherever you put in whatever exponent you want. After you hit shift, you'll see a little yellow. The box is now in the hook, so you can change the number that's inside of the hook. I'll come around and help people if it doesn't make sense, okay? I'll do a question in the homework ones. Okay, so you should be able to go shift, hook. It'll prompt you to put the number in the hook. In this case, we want 4. And then you go down into inside of the hook, or the square roots, or the 4th root in this question, and put your 1296. Hit equals. You should get an answer of 6. I don't know that off the top of my head, and I don't expect you guys to know that off the top of your head. That's what the calculator's for. I don't think your iPhone calculator is doing that for you. It might, I don't know. It does. Okay, these are nice. If you guys are gonna walk around and if you are gonna continue in math, these are nice to have, right? If you're gonna go about your daily day-to-day life, your iPhone calculator will get you by. Okay. Okay. Now, next one. A little trickier. We can actually get a number, right? You can say type that in your calculator or switch it. Well, let's switch it. Write yourself a little radical. Inside of the square root, we always put not square root, sorry, I keep calling them square roots, the radical, the root. You can put the bottom of the rational exponent. So we get the square root in this one, that's a nice one. And the remainder is 25 cubed. Okay, so remember what this reads? It's 25 cubed square rooted. Okay, so you're going to type in 25 cubed, and you might even actually be able to type that directly in the calculator. You might not have anything to worry about. You can probably hit the square root button, hit 25, and then cubed. It'll probably spit out the answer for you, no problem. I think that's a little easier to do than typing in the rational exponent, to be quite frank with you. To have to hit this to the 1 over whatever, right? I'm not a fan. I like the square roots of the radicals. Oops, I didn't hit equals. Anybody get an answer? You get 125? Okay, this reads again, it's 25 cubed square rooted. Okay? Problem with the fourth one, sorry. We got a negative exponent again. Don't like that. Rewrite it as 1 over 343 to the 2/3. Right? You could say, okay. Oh, sorry guys, one sec. I've realized something that we did that was not right. One sec, sorry. Right above. We got an answer of 6, but it's not 6, it's 1 over 6. Sorry. Did we see that? Our original, right here, sorry. It was 1 over the bottom, so it's 1 over the 6. Sorry. You just throw a 1 over that 6 as the answer. The reason why I thought of that is because we're going to do the same thing right here. So we get 1 over, write your little radical, 343 squared. Okay, we can say, okay, 3, you could build this in your calculator again. Should get 1 over 49. Okay. A lot of this is calculator exercise, but there is some preliminary work that you have to get to in order to actually type it in. Okay. What is this? Oh, I shouldn't have written that. What is this? Do you see a number inside that hook? So if there's no number, it's implied that it's a squared. Now, some people could probably type this in your calculator again, but if you couldn't, because you were on an iPhone calculator, then we could rewrite this as being 49 over 64 to the power of what? What's the exponent on this one? Remember, whatever's inside of the hook comes up and becomes the bottom of the rational exponent. So it's 1 over 2. What I like about this is it gives you the why behind how answers come to be. It's not just a leap of faith with how the calculator spits out numbers. You're going to kind of like provides context, and then you guys have an understanding of like, oh, this kind of makes sense or it doesn't make sense. You know what I mean? So how do we deal with this situation where I have inside the bracket raised to an exponent and it's a fraction? Well, you distribute the exponent to everything inside of the bracket, right? And so we get 49 to the 1/2 over 64 to the 1/2. And if you've been following along at any point over the course of this afternoon's lesson, or like this second part of this morning, right? You'll know that anything to the power of half is the square root. That's another way of writing it. So you got to ask yourself, okay, what's the square root of 49? 7. What's the square root of 64? 8. Done. Okay, I got one more for you, and then we're almost done for today. Okay. Same thing, just a little bit more complicated of a rational exponent. Got to put that rational exponent on everything inside of the bracket, and then evaluate. Okay, so let's go. We're going to have 36 to the power of 3 by 2 over 25 to the power of 3 by 2. Now we know what happens here. We know this is going to be equal to the square roots of 36 cubed over the square root of 25 cubed. Okay, let's do those individually. We'll do the top and then the bottom. You should get 216 in the numerator, and you should get 125, and I don't know if we're going to reduce that. No, that's it. You're done. Okay, I will give you sheets, and we will do the same thing as yesterday. We'll kind of pick it up in the morning. Okay, that's it. I will upload both.